Welcome to Astronomy Daily, your cosmic connection to the latest happenings beyond our atmosphere. I'm Anna, and today we're exploring a fascinating array of space discoveries and developments that remind us just how dynamic our universe truly is. In today's stellar lineup, we'll dive into NASA's SphereX Space Telescope, which has just begun its ambitious mission to map the entire sky in unprecedented detail. We'll also check in on the ongoing efforts to revive the silent Lunar Trailblazer Orbiter that went quiet shortly after launch. Then we'll explore a truly mind-bending discovery, an enormous ring of galaxies that's challenging our fundamental understanding of the universe's structure. If that wasn't enough cosmic intrigue, we'll track a piece of space history as a Soviet-era Venus probe from the 1970s makes an unplanned return to Earth after more than 5 decades in orbit. And finally, we might be getting closer to answering one of our solar system's biggest mysteries. Is there a 9th planet lurking in the distant reaches beyond Neptune? Researchers have uncovered compelling evidence in decades-old data that could point to this elusive world. So, strap in for a journey across the cosmos as we explore these fascinating developments together. We'll kick things off with a story update. After weeks of preparation and testing, NASA's SphereX Space Telescope has officially begun its scientific mission, marking an exciting new chapter in our exploration of the cosmos. Launched on March 11th, the observatory has spent the last 6 weeks undergoing rigorous checkouts and calibrations to ensure everything is functioning properly. Now it's ready to create something truly remarkable, a complete map of the entire sky. What makes SphereX special isn't just that it's mapping the sky. Other telescopes have done that before, but rather how it's doing it. The observatory is capturing roughly 3,600 unique images every single day, observing in 102 different wavelengths or colors of infrared light that are invisible to the human eye. This spectroscopic approach will give astronomers unprecedented insights into the universe around us. From its orbit around Earth, SphereX looks outward into space, constantly shifting its view. The spacecraft completes more than 14 orbits per day, passing over the poles in a north-to-south pattern. Each day, it photographs one circular strip of the sky. As Earth moves around the sun over the course of 6 months, SphereX's field of view gradually shifts until it has observed in every direction. The mission's primary goal is ambitious: to help answer fundamental questions about the origins of our universe. By mapping the positions of hundreds of millions of galaxies in 3 dimensions, SphereX will search for clues about cosmic inflation, that mind-bending moment in the first fraction of a second after the Big Bang, when the universe expanded a trillion-fold. Jim Fanson, the mission's project manager at NASA's Jet Propulsion Laboratory, noted the beautiful symmetry in this approach, saying, "We're going to study what happened on the smallest size scales in the universe's earliest moments by looking at the modern universe on the largest scales." The telescope doesn't use moving mirrors or detectors like some other observatories. Instead, the entire spacecraft shifts position using reaction wheels that spin inside it to control its orientation. When it takes a picture, the light is captured by 6 detectors, each producing a unique image at different wavelengths. These groups of 6 images are called an exposure, and SphereX takes about 600 exposures daily. Over its 2-year primary mission, the telescope will create 4 complete maps of the sky. But SphereX isn't just looking for clues about the universe's beginnings, it's also searching for the building blocks of life. The observatory will examine interstellar clouds within our own galaxy, making over 9 million observations to map water and other key ingredients for life. This could help scientists understand how compounds essential to life on Earth formed and evolved throughout the cosmos. Jamie Bach, the mission's principal investigator, expressed excitement about the telescope's performance, saying, "The performance of the instrument is as good as we hoped. That means we're going to be able to do all the amazing science we planned on, and perhaps even get some unexpected discoveries." After 12 years of planning and development, SphereX is now operational and beginning to unravel some of our universe's greatest mysteries, one infrared image at a time. Next, let's pay a visit to NASA's Never Say Die department. I made that up. However, NASA is still holding out hope for its Lunar Trailblazer spacecraft, which went silent just 1 day after its February 26th launch aboard a SpaceX Falcon 9 rocket. Despite more than 2 months of silence, mission controllers haven't given up on the $94 million lunar orbiter. The situation became concerning shortly after launch when the mission team determined that the 440-pound spacecraft was spinning slowly and running dangerously low on power. The probe couldn't properly orient itself to harvest enough sunlight with its solar panels, preventing it from charging its batteries as planned. Now, engineers see a potential window of opportunity. According to NASA's latest update, modeling indicates that lighting conditions from May through mid-June could be favorable enough to provide sufficient sunlight on the spacecraft's solar panels. This might recharge the batteries to operational levels and potentially allow ground controllers to regain command of the vehicle. There's cautious optimism that if contact can be reestablished, the mission might still be salvageable. NASA officials stated that if they can command the spacecraft again, and if the propulsion system remains functional after thawing, and the scientific instruments are still operable, they may be able to guide Lunar Trailblazer into its intended elliptical orbit around the Moon. The mission team has been able to track Lunar Trailblazer's precise position using ground-based equipment, which has been crucial in planning recovery efforts. If they do reestablish contact, NASA will conduct a thorough review to determine whether the mission can proceed or should be terminated. However, if no signal is received by the end of this favorable period in mid-June, the agency will begin procedures to officially close out the mission. Lunar Trailblazer was designed with an important scientific purpose, mapping the Moon's water stores from lunar orbit. This information is considered vital for NASA's Artemis program, which aims to establish one or more bases near the Moon's south pole, an area believed to contain significant deposits of water ice. Understanding the distribution and accessibility of these water resources could prove crucial for sustained human presence on the lunar surface. Interestingly, Lunar Trailblazer wasn't the only spacecraft on that February launch to encounter difficulties. It shared its ride to space with Athena, the second moon lander built by Houston-based company Intuitive Machines. While Athena did successfully reach the lunar surface on March 6th, it toppled over shortly after touchdown near the Moon's south pole, cutting short its planned 10-day mission. The coming weeks will be critical for Lunar Trailblazer as engineers watch closely for any signs of life from the silent spacecraft, hoping that the changing solar conditions might just provide enough power to bring it back from the brink. Next on today's story rundown, a startling discovery in the depths of space is challenging our fundamental understanding of the universe. Astronomers have identified a colossal structure dubbed the Big Ring, an almost perfect ring of galaxies measuring an astonishing 1.3 billion light-years in diameter. This enormous cosmic formation appears in light that has traveled 6.9 billion years to reach our telescopes, meaning we're seeing it as it existed when the universe was roughly half its current age. What makes this discovery so remarkable is that it simply shouldn't exist according to our current cosmological models. The standard model of cosmology is built upon what's called the cosmological principle, the idea that on a large enough scale, matter should be evenly distributed throughout the universe. Theoretical calculations suggest structures shouldn't exceed about 1.2 billion light-years in size, yet the Big Ring dramatically exceeds this limit. The discovery was led by astronomer Alexia Lopez of the University of Central Lancashire and presented at a recent American Astronomical Society meeting. Even more intriguing is that this isn't the first megastructure Lopez and her team have found in this region. In 2021, they announced the discovery of the Giant Arc in the same area of sky and at the same cosmic distance. That structure was nearly 3 times larger than the theoretical size limit. Neither of these two ultra-large structures is easy to explain in our current understanding of the universe, Lopez explained, and their ultra-large sizes, distinctive shapes, and cosmological proximity must surely be telling us something important. Upon closer inspection, researchers determined that the Big Ring isn't actually a perfect circle, but more of a corkscrew shape that appears ring-like from our vantage point. This rules out the possibility that it's a baryon acoustic oscillation, circular arrangements of galaxies formed by acoustic waves in the early universe, which typically measure around 1 billion light-years across. The presence of these enormous structures raises fascinating possibilities. Some astronomers suggest they could be evidence supporting alternative cosmological theories, such as Roger Penrose's conformal cyclic cosmology, which proposes the universe goes through endless Big Bang expansion cycles. Another possibility is that they represent cosmic strings, theoretical defects in the fabric of space-time that formed as the universe expanded in its earliest moments. Finding multiple ultra-large structures in close proximity also presents a statistical anomaly. As Lopez noted, we could expect maybe one exceedingly large structure in all our observable universe. Yet the Big Ring and the Giant Arc are two huge structures and are even cosmological neighbors. This discovery adds to a growing list of observations that don't neatly fit within our current understanding of the universe. The best path forward may involve finding more such arrangements scattered throughout the cosmos, potentially hiding in plain sight in our astronomical data. Whatever the Big Ring ultimately proves to be, it serves as a humbling reminder that the universe remains full of mysteries, even in its largest and most fundamental structures. A relic from the space race era is about to make an unexpected return to Earth. Cosmos 482, a Soviet spacecraft originally designed to explore Venus back in 1972, is now on track for an uncontrolled re-entry into Earth's atmosphere around May 10th. This half-ton piece of space history never fulfilled its intended mission due to a rocket malfunction that left it stranded in Earth orbit instead of heading toward our neighboring planet. For over 5 decades, 53 years to be precise, this abandoned spacecraft has been silently circling our world in a highly elliptical orbit that has gradually degraded over time. Dutch scientist Marco Langbroek, who's been tracking the object, predicts it will come plummeting down at approximately 150 miles per hour if it remains intact during re-entry. What makes this situation particularly interesting is the spacecraft's specialized design. Cosmos 482 was built to withstand the incredibly harsh conditions of Venus's atmosphere, which is much thicker than Earth's and filled with carbon dioxide. This robust construction means there's a significant possibility that the spacecraft could survive its fiery descent through our atmosphere rather than burning up as most space debris does. The surviving component is believed to be the landing capsule itself, a spherical object roughly 3 feet in diameter, weighing about 1,000 pounds or nearly 500 kilograms. Although experts doubt that its parachute system would still function after so many years in the harsh environment of space, the heat shield might remain effective enough to protect the craft during re-entry. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics noted that it would actually be better if the heat shield fails, causing the spacecraft to burn up during its atmospheric dive. Otherwise, we could have a half-ton metal object falling from the sky. While this sounds alarming, Langbroek emphasizes that the risk to people on Earth is relatively small, comparable to that of a random meteorite fall, several of which occur each year. The spacecraft could potentially re-enter anywhere between 51.7 degrees north and south latitude, encompassing a vast area from as far north as London and Edmonton down to near South America's Cape Horn. Given that most of our planet is covered by water, the odds favor an ocean splashdown rather than landfall. However, the exact location remains unpredictable at this time. This event adds to a growing list of uncontrolled re-entries in recent years, including a Chinese booster rocket in 2022 and the Tiangong-1 space station in 2018, both of which fortunately ended without incident. And to wrap up today's stories, could we be about to solve a major space mystery? In what could be the most significant development in our solar system's outer reaches in decades, astronomers have uncovered compelling evidence for the long-hypothesized Planet 9 by examining infrared surveys conducted 23 years apart. This potential new member of our planetary family has been hiding in plain sight, buried within archival data from 2 different space telescopes. The detective work was led by astronomer Terry Long Fan of Taiwan's National Tsinghua University, who devised an ingenious method to hunt for the elusive planet. The team compared infrared images from NASA's IRAS satellite, which operated in 1983, with those from JAXA's Akari spacecraft, which collected data between 2006 and 2011. They were searching for objects that appeared in one position in the 1983 data and had moved by the time Akari looked at the same region of sky. What makes this discovery particularly credible is that they found an object that moved exactly the distance that would be expected for a large planet in a distant orbit over that time period. The object appears in the IRAS imagery and then shows up again in Akari's data approximately 47.4 arc minutes away, consistent with the slow movement of an extremely distant planet. To rule out false positives, Fan's team carefully accounted for parallax effects caused by Earth's movement around the Sun and eliminated fast-moving nearby objects by examining hourly changes in position. Their meticulous approach has yielded what appears to be the most promising Planet 9 candidate to date. Based on the object's brightness in both infrared surveys, researchers estimate it would be more massive than Neptune, significantly larger than the super-Earth-sized body they initially expected to find. This came as a surprise, as previous surveys had already ruled out the possibility of Jupiter or Saturn-sized planets at these distances. If confirmed, this object would currently be located approximately 700 astronomical units from the Sun. That's 700 times farther than Earth's distance from our star, or about 65 billion miles away. Its orbit appears highly eccentric, potentially bringing it as close as 280 AU and as far as 1,120 AU from the Sun. The mystery of how such a massive planet ended up in this remote region remains. Fans suggest two possibilities. Either it formed closer to the Sun, near where our known giant planets developed, and was later gravitationally scattered outward, or it was a rogue planet captured by our Sun's gravity during the early days of the solar system. While this isn't the first potential Planet 9 candidate, astronomer Michael Rowan Robinson found a different object in the IRAS data in 2021. Fan's discovery holds more weight because it appears in two separate data sets taken decades apart. Definitive confirmation will require detecting the object in current observations. With advanced instruments like the soon-to-launch Nancy Grace Roman Space Telescope, the Vera C. Rubin Observatory, and the already operational dark energy camera, astronomers now have a specific target to investigate. After years of theoretical debate about Planet 9's existence, we may finally be on the verge of officially welcoming the newest member of our solar system family. That wraps up today's journey through our fascinating cosmos. From NASA's SphereX telescope beginning its ambitious all-sky mapping mission to the potential discovery of the elusive Planet 9 hiding in decades-old data, the universe continues to surprise and challenge us. We've explored the mysterious Big Ring structure that defies our cosmological models, NASA's ongoing efforts to revive the silent Lunar Trailblazer, and even tracked a Soviet-era Venus probe making its way back to Earth after 53 years in orbit. I'm your host, Anna, and I want to thank you for spending time with me today, exploring these cosmic wonders. The universe is vast and full of mysteries waiting to be unraveled, and we'll continue bringing them to you right here on Astronomy Daily. Visit our website at astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes. You can also find us on social media by searching for Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, Instagram, and TikTok. Remember that the same curiosity that drives astronomers to search the cosmos is within all of us. So until our next cosmic conversation, keep wondering, keep questioning, and most importantly, keep looking up.